Now, here again, we confront the paradox of REM sleep. So the thalamocortical neurons are in this depolarized tonic firing mode state during REM sleep, just as they are during wakefulness. And this is presumably one reason why there are cogent patterns of activity in our thalamocortical networks that might be consistent with having a dream, for example. So while the information is not being derived from outside of the brain, information is being resurrected from within the circuits that have been modified by previous experience. And we have these hallucination-like experiences that we call dreams. Now you may be wondering why it is that sometimes you have really vivid dreams and sometimes you might think that you're not dreaming at all. Well, we've already made the point that we think we all have dreams every night since we have cycles of REM sleep every night, unless there should be a disorder of sleep present. And the reason why you may not remember a dream on any one given night's sleep may simply be that you didn't wake up while that dream was happening. If you do find yourself going through a period in your life where you are recalling many vivid dreams, that's probably an indication that you're not getting very good sleep and that you are waking up repeatedly during these bouts of REM sleep. So while it's quite normal to remember a dream, I think if you find yourself doing that more and more frequently, then that might be a sign that your sleep is being more disrupted than it ought to be. Speaking of sleep disorders, let's conclude our discussion of sleep by considering just a few common disorders of sleep, beginning with probably the most common one of all, insomnia. So insomnia refers to impairments associated with the inability to either fall asleep, to stay asleep, or to experience the normal restoration of energy and vigor that sleep ought to provide. So insomnia, we think, affects about 15% of the population, and it can come from a variety of sources. One fairly common cause of insomnia is simply ingesting too much caffeine. So relative to a control subject that is showing these nice cycles down through our non-REM stages of sleep, back up to REM, and then back down to stage 4, stage 3 sleep through the night, this individual who has consumed an excessive amount of caffeine is only hitting slow wave sleep for very brief periods of time and only in the first couple of hours of sleep. So notice that the overall duration of sleep in this subject is quite short, just a few hours compared to a normal 8 or 9 hours of sleep in a night. And the amount of time that's spent in stage 4 sleep is far from normal with this overly caffeinated individual. So again, what this person has done is they've blocked their adenosine receptors, which presumably is not activating the ventrolateral preoptic area sufficiently to counteract the stimulating systems that are otherwise trying to promote wakefulness. Now also shown here is benzodiazepine, which is a form of sleeping pill, and what benzodiazepines do is facilitate currents that are flowing through those GABA-A receptors that are being activated by endogenous GABA. And notice that with a benzodiazepine on board, one reaches stage 4 sleep much more quickly and then has much more extended periods of this deep stage 4 slow wave sleep compared to control subjects. So insomnia can be treated in various ways with pharmaceutical measures or with various behavioral measures, but it's one of the most common disorders of sleep that we have in our population. Another disorder of sleep is when we misalign ourselves with our circadian rhythms. So there's a condition called circadian rhythm disorder, and this can happen for a variety of reasons. There can be physiological causes for circadian rhythm disorder. There can be lifestyle choices, such as shift work, or simply choosing to stay up very late at night and and not get a proper night's rest on a regular basis, that can result in a drift in one's circadian alignment to the entrainment that our environment is trying to provide for us. Well, here I am speaking to you at night with electrical lights illuminating my environment when perhaps I ought to be drifting off to sleep right about now. So there are various ways in which we manipulate our environments and change our lifestyles that run the risk of upsetting the alignment that we ought to have with our environment. Well, another relatively common disorder of sleep is called sleep apnea. So sleep apnea results in a cessation of breathing during the sleep. Now, this can be quite a serious problem, obviously. And so this typically results from a mechanical obstruction from the airway. So people that are somewhat obese are at risk for this. As our muscle tone begins to relax, as we're entering our deeper stages of sleep, especially if we have some excessive weight around the region of our neck, the region of our pharynx can actually collapse down upon our airway and occlude the flow of air down into our trachea. And once that happens, then obviously we're not breathing normally, and carbon dioxide builds up very quickly and can induce a reflexive, forced inspiration of air. And that act can be very disruptive. It can wake us out of sleep. And so what we see in this slide here is a record of someone who is attempting to sleep with sleep apnea. And we can see that they never enter the deeper stages of sleep at all. They are simply bouncing around between being awake and being in the lightest stages of sleep, and having quite a fitful night of it. So you can imagine why such individuals really struggle so much in their waking state, fighting off drowsiness and the tendency to actually fall asleep during times when it would be inappropriate to do so, because they're not getting a proper night's rest when they ought to be in a situation of cycling down into those deeper stages of sleep that this condition is denying them. So again, thankfully there are treatments for sleep apnea. The most common apnea is a positive pressure system, which is designed to keep that pharynx from collapsing down upon the airway during the progression into deeper stages of sleep. The next sleep disorder I'd like to mention is called narcolepsy. Now, narcolepsy is sometimes called a REM sleep attack or sleep attack. What this is a condition that allows for the intrusion into the waking state of fragments of the state of body and brain that we normally associate with REM sleep. So typically, people who are having these sleep attacks, they're not actually asleep, but they're having elements of REM sleep intrude into their conscious state. So this can be a terrible condition to have to live with, because the full-blown experience of REM sleep is seemingly right at the threshold at any moment. So, for example, one common condition associated with these attacks is cataplexy. And cataplexy refers to a partial or perhaps even a complete paralysis, consistent with the paralysis of large skeletal muscles that we see during normal REM sleep. So imagine these attacks intruding at any moment during your normal conscious state. This is what people with narcolepsy have to experience. And in a rather cruel twist, in the experience of an individual suffering from this condition, these attacks are often brought on by emotional experiences. Intense emotions, often very intense positive emotions, such as a laughter at a pleasant and unexpected experience of some sort. That might be sufficient to induce one of these attacks. Now, what's going on here, we think, is a mutation in either the gene that produces this important peptide, orexin, or the receptor for this peptide. One way or another, it seems as though in people who have narcolepsy, there is a mutation that is affecting the function of the orexin hypercretin system. And this is going to interfere either with the ability to sustain the awake state, or it's going to interfere with the regulation of those systems that are promoting the onset of REM sleep. Now, we know so much about narcolepsy because of the discovery of some animal models that, like human patients who have narcolepsy, have mutations in the genes for these critical components of this orexin system. So thanks to these animal models and the research that's going on with them, we are beginning to understand much better how to approach the intervention and the care of these people that have what potentially could be a life-threatening sleep disorder. And then lastly, I'd like to just mention restless leg syndrome. This is a sleep disorder characterized by a feeling in the extremities, particularly the legs, that movement is necessary in order to relieve a sense of unease. This might feel like an itch, it could feel like a tingling sensation. Often it's quite hard to describe, but it's a sensation that drives a person to want to move their legs in order to achieve some measure of relief. Well, restless leg syndrome has been associated with a deficiency in iron within the dopamine neurons of the substantia nigra pars compacta. And this has suggested that perhaps there's some deficiency in the dopaminergic system, presumably projecting to the putamen, that component of the striatum that is associated with the loops that govern the movements of the arms and the legs. So perhaps there is some disorder that is manifest at the level of basal ganglia circuitry that is providing for this urge or this impulse to move the legs to achieve some resolution to these feelings. So, as I think this tutorial has made clear, sleep is a very complicated business. There are a number of neurochemicals that are involved in regulating the transitions of states of body and brain. We're beginning to learn more about them, and there are lots of opportunities for things to go wrong, either because of disease or disorder, or now more commonly because of pharmaceutical agents and dietary factors that we take into our bodies that interfere with the normal operation of these systems. So if you are in the healthcare professions, you should know quite well how the pharmaceutical agents that you may be prescribing or interacting with your patients are affecting their sleep cycles. And I hope this tutorial has emphasized for you how critically important a good night's rest is for promoting health and wellness. And we need to be all the more vigilant to protect this important aspect of what it means to maintain our life on a healthy trajectory, when there are so many opportunities for us to interfere with this process, everything from a morning cup of coffee to the lights that illuminate our environments in the nighttime. Well, I think I've probably said enough about that subject, and after all, it is getting on into the evening, and I'm feeling my adenosine levels rising and my orexin levels lowering, so I know it's about time for me to turn in. So I'll see you next time when we will dive into the limbic forebrain and talk about those brain systems that are engaged in the experience, in the expression of emotion. So I'll see you next time, and otherwise, I hope we all have a good night's rest.